Hello everyone, this is Bandgar working as an assistant professor at Department of PH345 Digital College Class. Today we have to going to discuss TYBSc paper 5 semester 4 advanced electronics. Today we have to going to discuss chapter 3 digital signal condition. Starting with first point, digital signal condition. So why it is required? What is the advantages of digital conditions? Digital signal conditioning is process control, means finding a way to represent analog process information in a digital format. Digital electronic systems require data to be presented to them in a digital format. That is, the data have to be digital conditioned. Computers are digital electronic devices, so all the information they work with has to be digital format. Use of computer in control systems in particular can be very important. A computer can control multi-variable process control system. Non-linearities in sensor output can be linearized by the computer. Complicated control equation can be solved quickly and modified as needed. Networking of control computer allows a large process control complex to operate in fully integrated fashion. Next concept is the digital fundamental, a working understanding of the application of digital techniques to process control requires a foundation in basic digital electronics. A digital formation, the use of digital techniques in process control requires that processes variable measurements and controls information be encoded a digital form. The digital signals are simply two binary labels as a high state and low state. So high state is denoted by capital H or 1, or low state is denoted by capital L or 0. The digital words are assemblages of digital labels to construct a binary number, often called as 1. The individual digital labels are referred to as bits of the word. So 1, 0, 1, 0, 1, 1. So base 2. A 6-bit word consists of 6 independent digital labels. Next one is the decimal whole number. So here encoding analog data into a digital word is to use the straight counting of this, that is the base 10, and binary number. And next one is the octal and hexadecimal number. So octal has a base 8, 3, 0, 7, that is the binary 0, 0, 2, 1, 1, 1. And example 0, 0, 2, base 2 is represented by 0, base 8, or 1, 1, 1, base 2 is represented by 7, base 8. Or another number 1, 0, 1, 0, 1, 1, base 2 is represented by 53, base 8. Hexadecimal number is base 16, or it is counting from 0 to f. So here first 10 number is 0 to 9, remaining 6 number is represented as a alphabet. The hex number is denoted by capital H or small h by the subscript of 16. So 0, 0, 0, 2 bar, that is the binary number, is represented by 0h. Last one is the 1, 1, 1, base 2 is represented by h. There is no 8. Next one is the fractal binary number. Although not as commonly used, it is possible to define a fractional binary number in the same manner as whole numbers, using only the 1 and 0 of this counting system. Such number, just as in the decimal framework, represent divisions of the counting system to values less than 3, and 10 is equal to b1 to raised to minus 1 plus b2 to raised to minus 2 up to b m to raised to minus n. So where m is equal to number of digits in base 2 number, or b1 b2 up to bm, it is base 2 number less than 1, or n10 base 10 number less than 1. Next one is the Boolean algebra. So Boolean algebra is a mathematical procedure that allows the combination of true or false condition in various logical operations by equations so that conclusion can be drawn. Example, consider a mixing tank for which there are 3 variables of interest. First one is the level, second one is the pressure, and third one is the temperature. The problem is that we must signal an alarm sound where certain combination of conditions occur among these pairs. So we denote a water level by the pressure by the temperatures and assume the set point values have been assigned to each variable so that the Boolean variables are either 1 or 0 as the physical quantities are above or below the set point values. The alarm will be triggered when the Boolean variable D goes to the logic true state. Now see the how to this tank we have to control their water level, temperature, pressure. So B is the pressure, C is the temperature, A is the level, and D is denoted by the alarm. So there are three conditions alarm is sound. First one is the low level with high pressure, high level with high temperature. The third one is the high level with low temperature and high pressure. So that three conditions denoted by logical equations using a AND operation. So when is D is equal to 1, then alarm is on. So that three equations will be. So D is equal to A bar into D, then D is 1 for condition 1. D is equal to A into C, D is 1. Alarm is on for condition. D is equal to A, C bar into D, then alarm is on for condition. The final logic equation result from combining all three conditions so that if any is true, the alarm will sound D is equal to 1. This is accomplished with OR operation. So D is equal to A bar into B plus A into C plus A into C bar. So that is the operation of filling of. Next one is the concept of digital electronic. The electronic building blocks of digital electrons are designed to operate on the binary levels present on digital signal lines. The building blocks are based on families of type of electronic circuits that have their specific definition of power supplies and voltage level of the 1 and 0 states. The basic structure involves the use of AND and OR logic and NAND and NOR logic to implement Boolean equations. Next concept is the combinational circuit. It is a logic circuit made up from basic NAND, NOR and NOR gates that are combined or connected together to produce more complicated switching circuits. These building blocks of conditional logic circuits. So its function is specified by three ways. First one is the Boolean algebra. The algebraic equation check their operation by changing inputs. Second one is the truth table. It defines as the function of logic gate by providing a concise list that shows all the output states in tabular form. Each possible combination of input variable that the gate could encounter. Third is the logic diagram. It is a graphical representation of logic circuit which shows the writing and connection of each individual logic gate represented by a specific graphical symbol that implements the logic gate. So how to see the block diagram of logic combinational logic circuit, multiple inputs and one or more outputs. Next one is the classification of combinational circuits. So it divided into three categories. First one is the arithmetic and logical function. Second one is the data transmission, and third one is the code converter. First, arithmetic and logical functions is divided into four categories. First one, adder, subtractor, comparator, and programmable logic device. And data transmission divided into multiplexer, demultiplexer, encoders, and decoders. And code converter divided into binary coded decimal, that is the BCD, and 7-segment display, that is the SSD. So starting with first application, that is the multiplexer, it's shortly denoted by MUX. It is a special type of conditional circuits. There are n data inputs, 1 output, and m select inputs with 2 raised to m is equal to n. It is digitally circuit which selects one of the n data inputs and routes it to the output. The selection of one of the n inputs is done by the selected inputs. Depending on the digital code applied at the selected inputs, one out of n data sources is selected and transmitted to the single output wire. E is called the strobe or enable input, which is useful for the cascading. It is generally an active low terminal, that means it will perform the required operation it is low. The multiplexers come in multiple variations: 2 to 1 multiplexer, 4 to 1 multiplexer, 16 to 1 multiplexer, and 32 into 1 multiplexer. So, see the block diagram of multiplexer. There is the number of inputs and use the one single output by using a select line of strobe. Now, one example: 2 to 1 multiplexer. One multiplexer consists of set of and yield whose outputs are connected to a single OR gate. Becomes of this construction Boolean function in SOP, the sum of product form, can be easily realized using multiplexer. Each AND gate in the multiplexer represents a term. By connecting the function variables directly to the select inputs, a multiplexer can be made to select the AND gate that correspond to the minterm in the function. If minterm exists in a function, we have to connect the AND gate data input to logic 1. Otherwise, we have to connect it to logic 0. So that is the diagram 2 to 1 into the V1 of their corresponding output by using E enable to activate that IC, and downward arrow will show the select lines. That when it is the enable the mux 2 to 1 mux, then select the 0, will get the output D0, and when it is the select line 1, will get the D1. Now next concept is the multiplexer key. So there is the combines the number of mux and generates the higher mux. So consider we have to generate 8 to 1 mux tree by using a 2 to 1 mux. So we have to use a 4 to 1 mux at the beginning level. Then we have to use 2 and last one is the 1. So this property of this tree that mux says in the same level are share same selection signal. So here are many unnecessary transitions in the tree. Applying redundant transition. Assume 0 is selected at the first cycle, 3 is selected at the second cycle. Here all the outputs of mux cells are altered at the second cycle because the selection signals of mux of lower two levels are all switched. Though in 3 is correctly selected at least, all mux have output transition, only 3 transition mandatory for the function correctness. So see the both diagram. First one is the folder flexibility and below is the redundant by applying redundant transitions of the tree. Next one concept is the demultiplexer. It performs the reverse operation of a multiplexer, that is, it is a reverse one input and distribute it over several outputs. It has only one input and an output. M select lines at a time, only one input line is selected. By the select lines, the input is transmitted to the selected output lines. A demultiplexer is equivalent to a single pole multiple way switch. Demultiplexer come in multiple variation: 1 to 2 demultiplexer, 1 to 4 demultiplexer, 1 to 16 demultiplexer, 1 to 32 demultiplexer. So we have to know the one example 1 to 2 demults. There is the one input D and their corresponding output Y1 and Y2. E is the enable in and output is the select lines. So when it is the active or enable the 1 to 2 demults, then select line is 0, then output is the D0 or that is the 1, and when it is the 1, then output is the given input y. Now next concept is the demultiplexer tree. So here same we have to use the 1 by 16 demultiplexer and generates the 1 by 32 demultiplexer. So we have to use the IC 74154. So 1 as to 32 demultiplexer tree generates 2 using 1 to 16 demultiplexer. 1 to 32 demultiplexer has 5 select variables A, B, C, D and there are 32 outputs. If A is equal to 0, then choose only C, D. Data is directed one of the outputs 33. If A is equal to 0, then top IC chosen. If B is equal to 0, then bottom IC chosen. Depending value of the BCD, data is directed to one of the outputs. Next concept is the encoder. It is a combinational circuit which is designed to perform the inverse operation of the decoder. An encoder has n number of input lines and m number of outputs. An encoder produces an m-bit binary code corresponding to the digital input number. Encoder accepts an n-input digital word converted into a m-bit another digital word. Examples of encoder are priority encoder, decimal to BCD encoder, octal to binary encoder, hexadecimal to binary encoder. So following diagram shows the block diagram of encoder, number of n number of input lines and converted into a m number of output lines. Next concept is the priority encoder. Or example of encoder is the priority. This is the special type encoder. There gives the priority at the input levels. If 2 or more input lines is 1 at the same time, then input line with higher priority will be considered. There are 4 D0, D1 and D3 and D4 input and 2 output Y0 and Y1. Out of the 4 input, D3 has the highest priority and D0 has the lowest priority. This means if D3 is 1, Y0 and Y1 is 1 respective of other inputs. Similarly, D3 is equal to 0 and D1 is equal to 1, then Y1 and Y0 is equal to irrespective of the other inputs. So the following diagram shows the block diagram of priority encoder. D0 to D3, highest to lowest priority, lowest to highest priority, and their corresponding code. So here we generate shows the truth table of there when it is the 0, 0, 0, 1, 1, 0 and 1, 1 and their corresponding priority wise inputs. And last diagram shows the logic diagram by using a or and gates and generates their Boolean equations of outputs y0 and y. Next one is the decoder. Decoder is a combinational circuit, has n input and maximum 2 raised to n is equal to m outputs. Decoder is identical to a demultiplexer without any data inputs. It performs operations which are exactly opposite to those of an encoder. Example of decoder are following. First one is the code converter, BCD to segment, 7-segment decoder, mixed tube decoder, relay actuator. So that diagram shows the block diagram of decoder and input lines and outputs. Next example of decoder, that 2 to 4 line decoder. The 2 to 4 line decoder are the 2 inputs where D through E are the 4 outputs. In the given truth table explains the operation of decoder. It shows that each output is 1 for only a specific combination of inputs. So there is the 2 inputs A and B and their corresponding 4 outputs D0, D1, D3, D4. That is the priority lowest highest priority output when inputs are changes 0, 0 to 1 and their corresponding output D0, D1, D3. So that decoder is represented by 4 different equations by using A and not A. Their
corresponding logical